Have you ever looked up? I mean, really looked up. You crane your neck back, your hat falls off. You see something so tall it seems to poke a hole in the sky. In Shanghai, they built a 632-meter glass and steel corkscrew to seal it. The Shanghai Tower. It's one of the tallest buildings on this planet. It stands in Lujiazui, twisting like a glass dragon toward the heavens. People look at it and ask, how in the world did they build that? This isn't just a story about concrete and steel. It takes us from the bedrock of the earth to a hook hanging in the sky. This enormous structure isn't just for show. It's a vertical city. Offices, a high-end hotel, shops, gardens suspended hundreds of meters in the air. A symbol of Shanghai's place in the 21st century. But before it could become a symbol, it was a problem. A series of incredibly complex, mind-bogglingly huge problems. How do you build something that tall on soft, river delta soil? How do you stop it from swaying like a blade of grass in a typhoon? A team of very smart, very brave people answered those questions, one step at a time. The journey is a masterclass in ingenuity and sheer persistence. Digging a hole the size of a football stadium, pouring enough concrete to fill thousands of pools, lifting massive steel components higher than most airplanes fly. Architects dreamed up a shape that could cheat the wind. Engineers figured out how to make that dream stand up straight. We're going to break it down from the ground up. We'll follow the theme, from bedrock to skyhook, from a drawing to a landmark redefining a skyline. Let's peel back the layers, see the bones and brains of this glass giant. Numbers so large they blur, challenges so immense they seem impossible. Spoiler alert, they weren't. The tower is there. Before a single shovel could hit the dirt, there had to be a plan. And not just any plan. A plan for one of the most ambitious buildings ever conceived. The team behind it was Gensler. Lead designer Yun Xia envisioned more than another tall box. Right next to two other super talls, the Jinmao Tower. The Jinmao Tower, the Shanghai World Financial Center. The city didn't need another exclamation point. It needed something different, softer, more organic, to complete the trio with a dynamic flowing icon of China's future. The core idea, a twist, a beautiful 120-degree twist from base to top. Not just for looks, though it looks fantastic. This was genius-level engineering. With Thornton Tomasetti running simulations and wind tunnel tests, they found the spiral-disrupted wind forces, confusing the wind, preventing powerful vortices and violent shaking. Wind load reduced by 24%, and a vertical city with a conscience. 9 zones, sky lobbies, and atriums. Shanghai is basically built on a swamp. A slight exaggeration, but not by much. Soft, clay-like soils dominate the site. Not the bedrock you want beneath a 580,000-ton building. It's like a bowling pin on a bowl of jello. First problem, not how to go up, but how not to sink. Solution, create an artificial bedrock of epic proportions. Serious digging, a whole lot of concrete. It began with piles, and not fence posts, 980 massive piles, about a meter in diameter, bored deep into the earth, drilled to 86 meters, nearly a football field straight down, to reach firmer, sandier soils. Steel-reinforced concrete stilts bypassing the squishy layers to stable ground. The subterranean skeleton for the mega project. Then tie it all together with a mat foundation, 6 meters thick, taller than a giraffe, covering an area the size of a soccer pitch. A 63-hour continuous pour, 61,000 cubic meters, executed with zero margin for error. With the foundation secure, the tower began its climb. The strategy revolves around the core, the building's spine. Here, a massive 9-sided concrete structure running from foundation to top, the tower's primary strength and rigidity, housing the main elevator shafts, stairwells, and the building's arteries and nerves. Slip forming let the core grow continuously. Hydraulic jacks inching it upward as concrete poured from above. At peak, roughly a floor every 4 days. But the core needed help. Enter super columns. 8 enormous composite columns encircle the core. Steel outrigger trusses link core and columns like giant shelf brackets, making the structure act as one super stiff tube, a proven method against gravity, wind, and quakes. Cranes, perched on their creation, lifting thousands of tons skyward. No longer a hole, a presence on the skyline. Beat. The spine was set. Time to tame the wind. Building a 632-meter tower in a city that gets hit by typhoons is, to put it mildly, a challenge. Wind is the great enemy of the skyscraper. As wind flows around a tall building, it creates vortices that make it vibrate and sway. Too much sway makes people sick and can cause damage. They needed to tame the Pacific winds. Primary weapon, the asymmetrical twist. 120 degrees of aerodynamic advantage, more than aesthetics, a masterstroke. Unlike square or rectangular forms, the curved, tapering shape manages airflow. The wind can't get a grip. It breaks rhythmic vortex shedding, cutting wind forces by 24%, meaning less steel, a smaller foundation, and roughly $58 million saved. But even with the twist, it still sways. So they added a tuned mass damper. A 1,000-ton steel weight, suspended on the 126th floor, swinging opposite the wind to cancel motion. A giant shock absorber. It's become a kinetic sculpture visitors can see. Engineering on display. Section 5. A building within a building, the double-skin facade. One of the most revolutionary features is its skin. Not a single layer, a double-skin facade. Imagine the inner building, the core, and the places people work and live, wrapped in a second layer, like a ship in a bottle. A continuous atrium spirals up between the two glass walls, with a gap from 1 to 10 meters. Together, they create a thermal buffer, like a giant double-paned window. It insulates, cutting heating and cooling energy dramatically. A major reason it earned LEED Platinum. The atriums are the heart of 9 stacked zones with sky lobbies. Light-filled public squares, gardens, cafes, and shops in the sky. They're the tower's lungs, connecting people to nature. Over 20,000 panels, nearly 14,000 unique, installed by robots and climber cranes. A 3D jigsaw puzzle, hundreds of meters up. The result? A seamless glass ribbon that looks stunning and performs hard work. Form that serves people and the planet. Section 6. Up, up, and away. Build a vertical city 600 meters tall, and you must move people fast. The answer lies in the elevators, not average lifts. Technological marvels by Mitsubishi Electric, once the fastest in the world. They hit 20.5 meters per second, about 73 kilometers per hour. Ground to the 119th floor deck in under a minute. Designing for that speed needs aero cars and vibration control. Active guides tame the tiniest wobble with advanced brakes, even ceramic, for safety. You feel a slight pressure, then floors fly by. A zoning strategy. Super fast shuttles to 9 sky lobbies, then local double-deckers take you home. 2 cabs serving 2 floors at once. Doubling capacity, cutting weights. It's a subway system inside the building. Zoning saves space so the core isn't all shafts. Elevators pump the vertical city with precision. Section 7. The human element. A megastructure like this isn't built by robots. It's built by people, thousands of them. At peak, roughly 4,000 workers on site every day. Crane operators, steel workers, welders, concrete finishers, electricians, and glaziers. Around the clock, in heat, in cold, hundreds of meters in the air. This is their story of skill, endurance, and courage. Safety was priority 1. Helmets, harnesses, footwear, strict protocols, tools secured, cranes choreographed, daily briefings to review tasks and hazards. Dedicated safety teams enforced the rules. Canteens and medical facilities supported the workforce. Even the psyche at altitude was managed. Camaraderie and a buddy system kept people safe. Global architects, international engineers, a largely Chinese workforce, orchestrated to perfection. The finished tower is a monument to their collective effort. Conclusion. More than just a building, it's a statement. So, there it is, the Shanghai Tower. It stands on the banks of the Huangpu River, not just real estate, but a declaration. A 632-meter statement about ambition, ingenuity, and the future. From deep foundations to a peak that touches the clouds, a physical narrative of human problem-solving. Impossible height, impossible soil, impossible wind, made possible. A new benchmark for sustainable supertalls. Millions of hours, courage at height, precise engineering, visionary design, a global collaboration, East and West. Great architecture inspires wonder. It makes you look up. Keep looking up. What will we build next?